everyone. It's a great pleasure to welcome you here in Brussels today, thanks to our very kind host. We are starting officially, and only with 30 minutes late, the new WebVR workshop on WebVR authoring. So first, let me introduce myself. I'm Dominique Azalmacieux. I'm the one who has been spamming many of you over the past couple of weeks to get ready for this event. I work for W3c, the World Wide Web Consortium. Let me say a few words about W3c. Some of you may not be very familiar with what W3c is and what we do. So W3c stands for the World Wide Web Consortium. We are a standard setting organization for the web. I'm sure you've heard about things like HTML and CSS and JavaScript, and many of these technologies are standardized in W3c. So we are a consortium, which means that any company, any organizations can become member of W3c to participate to the conversations around these new technologies and standards. The organization was founded by Tim Berners-Lee, who also happened to have invented the web some 28 years ago. The way we work in W3c is we try to keep the web as open and interoperable as possible. So our work is to make sure that web technologies, when they come into your browser, that they will work the same in this and that browser. And for any technology, you can say, well, it doesn't actually quite work the same in this and that browser, but over time, it gets better, and hopefully it will always get better and better. And a key thing that we try to achieve in W3c is also making sure the technologies that we develop are royalty-free. That may not mean much for many of you, but what this means is that when you start building a web page or even a web browser, you don't have to pay anything to anyone. You can do it for free and without having to ask the permission to anyone. And to us, that's a great value of the web as a platform. It's not just building content and distributing it. It's making sure that anybody can build any content anywhere without having to ask anyone's permission. So that's a great value we try to defend by keeping our technology royalty-free. So why are we here? We think there is a great set of shared opportunities between the world of the web and the world of virtual reality. I'm sure all of us here are already convinced that virtual reality is a big thing, something very much worth exploring, building for, and developing for. And the web brings unique qualities to virtual reality. It allows to give it reach and to make it very easily startable experiences. One of the difficulties with VR is that right now it tends to be an on or off experience. We think that if you bring the web into the landscape, then it can be an experience that starts in a regular web page and then gets augmented in a virtual reality experience. So why are we here specifically? Why did we bring this community together? We think there is a number of opportunities and challenges with the existing WebVR technology for creating and deploying content and application and services. And the goal of bringing all of you here together is to get a better picture. Hopefully, it will also mean that you'll get to meet many of your peers, many people who have either similar or very dissimilar issues with the technologies, maybe future partners, future collaborators. It's hopefully going to be a great networking opportunities for all of us. Depending on what we identify during the workshops, there may be discussions about how do we follow up on those. Some of this may be how do we influence the standardization of WebVR to make it more workable for all of us as developers. It may be that we think there is a value in keeping the conversation we're starting today, conversations that have started also on the GitHub repository of the event over the past couple of weeks. So that's something that hopefully will emerge in the upcoming 2.5 days. I guess I will start the round of thanks. If we are here all together, it's not because I decided it, it's because a great set of people on the program committee helps make this event happen. So I'll ask all the program committee members to stand up just so that you can be identified. So two of them are already standing up. Martin is here, Billy is here. So first, Diego will be our chair during this event, Diego from Samsung, and he has been critical in making this event happen. Salvador from Mozilla has been chasing you for talks and presentation during the agenda. I already introduced myself. Indira couldn't join us, but she was also extremely couldn't be with us. You saw Martin earlier. All behave as well. We have a code of conduct that is links from the agenda. If you encounter any issue during the event, feel free to reach out to anyone on the program committee. We're also here to make sure that everyone is comfortable during the event. So please, let's make sure this event remains very professional. Another key thing in making this event happen, and I got an image that is not loading, sorry. So first we have a host. So how do I say the name in English? Do I say DigitYser, DigitYser? Okay. So DigitYser is hosting us here in a great building. We will hear from our host in a couple of minutes, but again, without a host, there would be no event. So thank you very much, Tanguy, for hosting us today. We also have sponsors. Both Google and Mozilla have been, again, critical in getting you food. So you should be very thankful to them. Hopefully we'll eat thanks to them. And we get coffee thanks to LucidWeb. Where is Lynn? Lynn and Fabien. So thank you guys for bringing us coffee. That's juice that will make us work for the upcoming 2 days. So thank you very much to our sponsors.
With Juan, for instance, who's over here, with Fabien from VR Lab Brussels as well, who organized quite a lot of WebVR events. We are really community dedicated. There is data science community as well over here, with Philippe, my co-founder, over here. He's the one taking pictures for my mom, I mean, hopefully. There is IoT as well, where we have, like, for instance, a workshop tonight. And blockchain, this is the big hype. I mean, this is big fun currently, but VR is the best, and we love VR. Where is Alejandra? In case you have any issues, Alejandra? Oh, okay, she's the one. In case you have any issues or stuff like that, logistic-wise, she's the one. I mean, go to her. Please note that if you want to come and work here, this space, this ground floor, you can come and work for free from 9 to 5 on weekdays. There is like a co-working space upstairs as well. If you want to organize events, if it is part of our verticals, I mean, please feel free to come and tell us, and let's see what we could do together. In the meantime, I mean, have fun and be kind to each other. So that's it. Oh, yeah.
So I think you've been welcome now. We'll start the actual meat of the agenda with a first discussion about where we are with WebVR and where the technology is heading. We'll hear from a number of browser vendors about their plans and their expectations around this technology. A few logistical aspects. You've been sent, or you'll be sent very shortly, a couple of links. One to the live streaming of this event. This event is being live streamed. So do not open that link here. We want to keep an internet connection for all of us. So do not use the live streaming. You're here. But if you have colleagues, friends, partners that couldn't make it and want to follow some or all of the conversations, that's what the live streaming will be for. I believe it will also be linked from the workshop homepage. Is that correct?
Yes, and we just sent an email.
Okay. You'll also be sent an invitation to join a Slack team for this workshop. So we will be exchanging links and comments and ideas. So if you have access to your email and want to create a Slack account to join the Slack team for this event, it's in your email. I'll also be taking notes of the discussions when I'm not speaking, at least. And I'll do that in a Google Doc. If anybody is interested in helping me taking good notes, that would be very much welcome. And in that case, I'll share the link to whoever gets in touch. So before we get into the various browser presentation, I was asked to make an announcement on behalf of the WebVR community group. So let me first say, where is WebVR today in the standardization landscape? And I'll give a few announcements with regard to this current status. So as I mentioned, W3c does standardization for web technologies. We have a well-defined process for this standardization. You go through various hoops to make sure that the technology you have developed is good for the web and is actually useful and used by both browser vendors and developers. WebVR hasn't started its standardization roadmap yet. It's still in what we call incubation. So it's still a work that is very much in exploration, in very rapid development in browsers. And right now that work was happening in what we call the WebVR community group, well named. Once we start the standardization work, we get into no longer a community group, but working groups. So right now this is the WebVR community group, but as many of you probably know, there has been a lot of announcements and interest in the past few months around augmented reality. And the question has been if and how WebVR could be used in the context of augmented reality as well. And some of these discussions have led to what has been referred to as WebVR 2.0, which right now is more a set of ideas and an actual specification. But the community group has recently decided to recognize that these efforts around augmented and mixed reality are becoming increasingly important, and as a result that the name WebVR was not reflecting the expected scope of the work. So the WebVR communities group is going to be renaming itself into the immersive web community group, so relating to the idea that it's no longer just VR, but anything about immersive experiences. So the WebVR community group will become the immersive web community group. And what is currently known as the WebVR 2.0 API will become WebXR, to refer to the variety of augmented and virtual realities. WebXR device APIs, again, to reflect that what the API is about is access to these device capabilities rather than the broader landscape of 3D audio and so on. So WebVR 2.0 will be renamed WebXR device APIs. It doesn't change the fact that WebVR 1.1 is available today and will remain available at least in the short term, and we'll hear more from the various browser vendors in their plans. There will be a migration plan in any case for anyone using WebVR 1.1 today. But since you're here, we thought you should know that there are bigger plans, and these plans also encompass augmented reality. So that's what I've been asked to do. I guess there may be also discussions around this after we hear from the other speakers. In general, something I haven't mentioned, but I did mention this event will be only as good as we make it. And a critically important component to that is that it's not the expert talking to an audience, it's a group of experts talking together. And so each session will be introduced by a set of talks, but then it's free for all. Everyone gets to participate, ask questions, bring challenges, and lead the discussion. So it's a very participative event that we want to build, not one where you just sit and listen, although I've imposed that on you for the past 20 minutes already. Diego, are you?
Yeah.
So we'll do the usual dance around laptops, which never works.
Or you just making time for me? Okay, so good morning. Now with the great news that we now know about the WebVR API, the new upcoming API.
Sorry, could you stay in the microphone
yes.
for the streaming, please?
What I'm going to do now is just a brief recap of the state of WebVR in its implementations in current browsers. So this is going to be a compilation of all the different browsers and the support that we have. Then we're going to move on into different specific browsers that are going to be mentioning their own updates. So first, to start, again, compilation of information that you can find in different sources. These are the browsers that to date are supporting the WebVR specification. First one, Samsung Internet for Gear VR. Why did I put this first one? Because it's the first consumer VR browser, started in December 2012. It's started with support for proper WebVR in April 2016. We have WebVR as an experimental feature that is found under the labs. We have specific APIs that can interact with our hardware, specifically the Gear VR, and also support for a 3 degrees of freedom controller since February of this year. Most recently, the latest update to the Gear Sport and Gear S3 include a Gear VR controller as well for the virtual reality experiences. If we move to another browser, we have Mozilla Firefox. So from Firefox, the big news is that it's shipping WebVR in stable since version 55. And please, Salva, correct me if I'm wrong. This is in August this year. They have experimental support in macOS since August as well of this year. Their browser supports the HTC Vive and the Oculus Rift on the Windows platforms. It's the first Windows browser that supports WebVR, and it is enabled in nightly for iOS. Moving on, Mozilla Servo. Only thing I'm going to say about Servo is that their support for Daydream, Gear VR, and Vive, and Salva is going to fill us on this with more information. Moving to Google Chrome, WebVR was launched officially on Chrome with Daydream support. It was announced in February. This is for mobile. It supports, as you know, a 3 degrees of freedom controller. WebVR is supported. WebVR support is conducted as an origin trial experiment, and it is enabled under the WebVR and Gamepad extensions flags. It includes support for Rift and Vive on the desktop. Next browser, Microsoft Edge. They announced WebVR development in September last year. They have already WebVR support in the latest Fall Creators Update, which came out this October. And of course, they support Windows mixed reality devices, which include 6 degrees of freedom controllers. Chromium, you can have WebVR behind these flags, similar to Chrome, and it works through Steam VR. Opera is not properly supporting WebVR, but they are using open VR APIs to detect the headset. They have announced plans to go into WebVR support, and they are allowing, at least now, native 360 video playback from the browser. Apple Safari, they joined the W3c WebVR community group July this year. They're not officially supported yet, but there's a polyfill that allows you to cover the experiences if you are on iOS devices. This is kind of like the latest and updated WebVR.rocks list with the browsers that we've seen here. You can see, depending on the platform that you want to target, the browsers and the operating systems, you would get the compatibility. Of course, you get a lot more checks if you take into account the polyfill. And this is the current kind of use picture from today at 3 a.m. in the morning. So you can see the support that there is for the WebVR specification. and my 5 minutes are up. So thank you very much. Hello, I'm Diego. I'm going to do a brief lightning update from the Samsung Internet. At the moment, this is a presentation that was, it's quite freshly baked with help with Damon Hernandez from Samsung Research America, and they are very sad that they couldn't join. So let's start with the lightning update. So as I just recently told you, Samsung Internet is the first consumer available VR browser. We have support for the WebVR specification since April last year. The feature itself, it's under the lab section in our browser. We have APIs that interact with the Gear VR as well, and there's support for a 3DoF controller as well. Now, on to newer information. This is the evolution of our browser for VR. First, we first had a beta back in the day in 2015, version 3.0. We shipped our first stable release in March of last year, where we introduced compatibility with the Android version of our browser. We had then proper WebVR support the next month in April. We shipped our second major release in August of 2016, in which we included multi-language keyboard support and USB on-the-go support as well, if you wanted to play files and media using the browser. Third major update is version 5.0, which included support for the Gear VR 3DoF controller. We included the curved screen now and featured media as well, as part of one of the features of the browser. And the latest and greatest version of the latest and greatest VR browser was shipped a couple of months ago, which includes now secret mode, content blocking, and customized content curation. The basic features of the Samsung Internet for VR, we have integration with Samsung Internet for Android, so this means that we can enable workflows that go from browsing in your phone to putting your phone in the headset and then continuing the browsing experience from the same point where you were on your phone. And then when you take your phone out of the headset, then you continue from that point as well. And we have synchronized video history and bookmarks as well. This is an example of how it would look if you put, for example, a video to play on the player itself. Of course, if you go into immersive mode, then you can immediately go in 360 mode and start playing natively in the browser as well. This is an image of how the featured media tab looks. We have access to hundreds of videos. They're organized by content providers, so we have YouTube, Vimeo, Discovery, Otoy, Naver, and YouTube VR. And these are things that we're constantly up with partnerships. We have specific APIs for our device. So the Skybox API, this is the way that you would programmatically do it. Basically, it allows you to put a different skybox on the browser when you're navigating inside of it. And you can have the web content in the page to change this skybox. You can do it in several ways. Either JavaScript, where you can have a custom skybox when you're entering the website. You can have a skybox that is provided by our partners, and as well the type of skyboxes that you can put. The type of skyboxes that you can put are either equirectangular images. You can have monoscopic cube maps, or you can have stereoscopic cube maps as well. So if you wanted to put a stereoscopic image as a background for a web page, you're able to do it. And as a final point, I just want to say that we are dedicated to the immersive web. We've been with WebVR 1.1 from the beginning, WebVR from the beginning. Support is now on by default. We have support now for WebVR navigation, and talking now about WebVR 2.0, or now as Dom just announced, WebXR and the Immersive Web Community Group. We are working with the standardization group to support future releases, and we are working with the community members in order to provide developer outreach. So part of our team in SR UK and SRA are dedicated to developer outreach, and if you have any questions, please do get in touch. And pretty much my 5 minutes are up, so thank you very much. Now, Angela. So, yeah, you can. If this works.
Oh,
Yeah.
okay. Yeah, I know. I don't know. Let's see.
Yeah.
Yes. Tricky. There is a clicker here, but hello. My name is Alba. I'm part of this workshop committee. I'm the responsible for the agenda, but I'm not going to tell you about the agenda. No more. You have the link, and now I'm here to update you about what is new in what is coming to Firefox, Servo, but most important, what is coming to WebVR in general. Okay. So, good news for Mac users. In mid-March next year, we will be supporting Mac only ATC Vive in Mac in Firefox. Perhaps Linux should wait until Firefox 60, but for Firefox 59, 2 versions more than the current Quantum one, we are going to support Mac OS with ATC Vive. Okay, I think this is very good news. Another new. Currently, sorry, Firefox offers probably the best experience, in WebVR. We are working on improving the stability and the frame rate and the timing. If you want more information of what subframe timing is a very cool thing, but I can answer it offline. And we are moving forward to be better at that. So expect more, even higher frame rates and a smoother experience in Firefox. And in Servo, we are experimenting with new technologies like multi-view or DOM to texture, which are some of these supporting technologies I'm going to introduce you right now. The first is WebGPU and WebAssembly. I don't know if you know what is WebGPU, but it's similar to Vulkan compared with OpenGL. And for those that don't want to know the technical details, let's say that when you tell the graphic card to draw something, you are actually using a high-level language. So draw this point, but this draw call is actually translated into several low-level instructions, and these low-level instructions are scheduled and validated and monitored, and every of these steps introduce a lot of, well, a tiny overhead, but sum up it introduces a huge overhead on the draw operation. And it's not a problem of only draw a point, you know, it's not that way. It's when you try to draw complex scenes. So WebGPU tries to get rid of this overhead by allowing you to control the composing low-level instructions for the high-level API like WebGL. And this is something really good because it enables better interoperability. So, you know, the OpenGL specification for desktop is one thing, the OpenGL specification for mobile is another thing. WebGL actually is based on the mobile version of OpenGL, but Vulkan aims to be universal across devices. Okay, so the point with WebGPU is to, which is the web the web version of Vulkan, is to provide a low-level set of instructions to control the GPU directly, and with that create your own graphic engines. Well, the point is to get rid of this overhead and get better performance. And WebAssembly. WebAssembly is not assembly, okay? It's a low-level virtual machine for the web. And as I was reading this morning in a thread started by Alan Russell, I think, it was not about replacing JavaScript. That's not the point. The point is to boost mathematical and bitwise and data transforming operations on the web. And we use a low-level virtual machine which is very, very easy to translate into actual machine code. Okay? So, what does WebGPU and WebAssembly mean? It means that we can transform, we can prepare for the web or transpile or whatever you want to call it, complete state-of-the-art game engines or graphic engines to web technologies, and so we can run those engines in the web. Okay. The first version of WebGPU, I think we will be landing in Servo, but I need to double check that. Well, next one. It's not working. Oh, okay. WebGL 2. We just landed WebGL 2, okay? But there is a lot of room for improvement because WebGL is a very, very new technology, and we need to get deeper into new optimization techniques. For instance, now high-level overview, excuse me for the inaccuracy, we can pass parameters from the JavaScript code to the GPU code more quickly. And this means less overhead, and that means higher frame rate and more stability for WebVR. Down to tester. This is a very interesting technology. This was available by the time, I don't know if you remember some Mozilla initiative called Firefox OS, but Firefox OS included something like this, a way to render the graphic buffer of a DOM element into another element, like a background, like something like that. So you can actually put an image, and inside the image, or a div, and inside the div you can do some magic to show the DOM representation, the visual representation of another DOM element, and that is what we are trying to bring to the web. But instead of any element, the proposal made by Google, I don't remember the engineer who presented this in the latest SIGGRAPH, but his proposition is about rendering iframes, okay? So you will be able to bind an iframe, the visual representation of an iframe, into a texture, and then make this texture part of your scene. And there are very cool demos out there showing curtains or soft bodies with actual web pages on top of them. Okay. Multiview. The problem with rendering in stereoscopic is that you need, the naive way to do it is to send the complete scene like if you were having a camera here in your right eye, and then send again the complete image for your left eye. That is the naive way to render a stereoscopic scene, and this, if you think about it, this sends every object of the scene twice. So with multi-view, we aim at saying, okay, this is the scene you need to render, and these are the different cameras. And this combination, this duplication actually happen at the GPU level. So we get rid of 50% of the draw calls from the clean code. And Pathfinder, and I finish with this. This is very new, very new, and this is a technique for rendering text in 3D. Okay, so with Pathfinder, we will be able to render clearer web fonts and fonts in general in a 3D space. And I think I run out of time, but I don't have any other word to say. Thank you. I did it at the beginning.
Okay, cool.
Good. Thank you.
Just to let everyone know that there's a hashtag that we are using, which is hashtag WebVR content 17. So just so we can group the tweets that are coming out and all the social media as well. All right.
Well, let's see. I'm going to hover around my laptop because it looks like this doesn't click. My name is Gordon Brander, and can I move the laptop over then? Yeah. All right. All right. Thanks for bearing with the technical difficulties. My name's Gordon Brander. I'm working on design for Chrome in VR, and yeah. Sorry. My name's Gordon Brander. I'm working on design for Chrome in VR, and I wanted to give a little bit of an update on what we've been working on with Chrome for VR in 2017, what we'll be working on in 2018, as well as a small update on WebVR. Just to kick it off, I want to talk a little bit about WebVR in 2017. So the last couple of years has just seen an explosion of exciting WebVR content. We've had all kinds of indie experiments that have been really exciting, pushing the boundaries of what can be done. And we've even had some early commercial use cases, things like movie promotionals and Wayfinder, and a whole ecosystem has sprung up around this space in order to support it. Everything from React VR to 3JS to Amazon Sumerian. So it's a really exciting time to be a part of this. I think 2018 is going to be more exciting still because 2018 is the year that WebVR is going to go mainstream. So we're going to have WebVR shipping unprefixed, not behind flags, in every single major desktop and mobile VR platform across the board. So that's pretty exciting because it means that we'll have reach across the board. As Dom said, this is also an exciting moment because the WebVR W3c group has decided to expand its purview beyond just WebVR, and we're also going to be tackling AR and mixed reality. So the new name for this group, it's going to rename itself the Immersive Web Community Group, and going forward, the term of use will be WebXR to refer to the scope of the API. This is the same effort that used to be known as the WebVR 2.0 spec. It'll be known as the WebXR Devices API specification in the future. I think the key thing to know here, though, is as we make this transition to a world where you can seamlessly target VR, AR, mixed reality, none of it really changes the focus for developers in the short term. If you author stuff in WebVR 1.1 today, that'll be the best way to build your skill set, and there will be a migration path forward into the future. So that's WebVR in 2018. I wanted to talk a little bit about Chrome VR as well. For folks that haven't seen it, Chrome VR, you can drop your phone into a Daydream device, surf the web in 2D. So click links, navigate the web, all that stuff. That's there today. You can also drop into immersive WebVR experiences, so hopping directly from a 2D site in VR into WebVR, and you can watch media. So any video on the web, you can click on full screen. Full screen in VR mode actually pushes the virtual screen back in physical space. It grows in size, so you get this nice cinema sort of experience, your own private cinema in VR. Coming up, Chrome has a rolling release model, so we're folding in new features all the time. Some new things that'll be coming down the pipe very soon will be full web search as well as voice search. Something I think to note with this crowd, with us WebVR authors, is a couple of things about authoring content for WebVR. So WebVR, we hand the entire experience to the content author. It's the content author's job to submit frames to the browser. The only thing that we do up front is we put a little bit of a toast that lets the user know how to back out. On Daydream, the way you do that is through the app button. This is the button that belongs to the particular app that is active. That toast fades away after 5 seconds. Other than that, though, the entire experience belongs to the content author. As part of this whole exploration, we've had to come up with some new design patterns as well. One issue is, as I mentioned before, it's up to the content author to submit frames. This can cause some interesting problems, like if an app hangs up, all we can show the user is a black screen. That's not much good. So what we actually do now is after 5 seconds, if the app has hung up, we'll display a screen that lets the user know and they can wait around. We're actually recommending a new best practice for content authors, which is submit your first frame immediately and just make it a splash screen, because from then on, the WebVR browser can do reprojection. It can offload, you can offload all the compute to the WebVR browser to take care of that for you while you do all of your cold start stuff. Finally, Chrome VR is coming to desktop VR. So we've got a patch in the works that's being worked on as we speak that'll enable it for Vive and Oculus. And, excuse me, we are also beginning to feature WebVR experiences directly on Daydream. So this is sort of the VR equivalent of PWAs. We're calling them deep linked WebVR applications. These are applications that sort of check all the boxes of good user experience, and then we're beginning to feature those right alongside native content in the Daydream platform. So that's pretty exciting. So before I lose my voice, that is me. Thanks, and I'll call it my 5 minutes.
We need to connect this one.
¿Qué tipo de conector tiene? Whatever connector is it?
HDMI. And I also have DisplayPort, it's at the back.
This
Okay, then you can connect
Perfect.
directly.
Thank you. Good luck. Some noise on the line.
Is it working?
Yeah, the HDMI signal is not received.
It was working.
It may be my laptop. So much for technical companies. Okay, hello everyone. Yeah, I'm going to talk a bit about how we are using WebRTC in combination with WebVR. Let me introduce myself first. I'm working for TNO. It's a Dutch research institute. I'm working for the networks department, so we are researching network technology, hence our experience with WebRC. For the past 2 years, we've been busy with our WebVR platform for social experiences. Yeah, sorry. So usually when you are in VR, you have this very nice experience in very beautiful environments, but very often you're on your own. So we are actually investigating how can you be together in VR. So you have these social VR style apps coming up, Old Space VR. There's also some guy I talked to already who has his own system. So what do we want? We want to have people to be together in VR, and we want it to be realistic. You want to feel like you are actually in the same room. So these are some examples of our experiments. The thing is with VR, we can create any environment we like. And because we are using WebRC, what we are doing, we are capturing a live video of someone and we are putting it inside VR. And the beauty of using the web platform is that because it's just a video element, we can put it anywhere. So you can see different use cases. So at this moment we are using web technology, we're using WebVR, we are using A-Frame actually, WebRTC, and it all runs on consumer hardware. For our capture we're currently using Kinect, but we are using a combination of video, imagery and a depth sensor, so we have multiple layers of information. But this, I can imagine that this will be replaced by phones in the future, because there already are phones which have both these sensors built in. We use the depth layer to extract the background from a person, and that way the person becomes transparent. So you can see in the top right image what this will look like without chroma keying. So this is actually done by the depth sensor. That way we can distinguish what part of the image is the person and what is the background. And because it is in VR, we can place the person virtually anywhere, as long as it's a static position at this moment. So that's where these positions come in. So we have the virtual table in the middle of the forest. Because the people are cut out, we can put them anywhere we want. Also another advantage of using WebRTC is that we can use screen sharing. So we can share any screen on your system. We can also place it in VR. So we have used this to watch a video together or play a game which is running actually running on your system. And well, because we can put it anywhere, you can play it together. So there the game is making sure that the content is the same. And this, we can place the people anywhere in the room. So that is, provides for some very nice experiences. So I will give a short movie about our experiment where we have this virtual table. It's actually a whole day picture of mine. And we have 4 people, and they are arranged in a circle around the table. And they can see each other, they can talk to each other. Let's see if the video will start. Yeah. So you can see them here trying to play rock, paper, scissors with each other. Current delay we are having is about 300 milliseconds, so for that purpose it's a bit difficult. But we're looking to improve this. But you can see the person can look around, he can look around the table, and they can see each other. And even though the HMD is still in front of the face, we notice that people, they don't really care. They can talk to each other. They notice the HMD, but they prefer the human interaction. This is for discussion. We are actually pursuing this further in the VR Together open research project. It's a EU research project where we are going to proceed from using 2D videos, we are going to proceed to using point clouds and 3D people. And there we are probably going to run into lots of interesting technical problems, for instance, how much data there will be and graphical performance. But this is planned for the coming 3 years. So maybe I'll see you then, and I hope I'll have good news. Quick takeaway. I think my time's already up. But so for WebRTC, we can use it to transmit audio and video data by combining it with WebVR, we can place this content anywhere we like, which allows for very creative, we can unleash our creativity to create very nice environments where people can meet and interact. Well, because we have built a platform, we can, it allows us to create these kinds of experiences. It's very easy to program this way. And that's about it. Thank you very much.
Okay, so now what I would like to do is let's start some conversation. We've seen more or less where the future of the spec is going. We've seen some of the examples. Is there any questions that you have for any of the people that have presented? Where do you see this going? Yes.
Yeah, what happened with Yeah, actually, that's the reason we removed that feature from Firefox OS. Oh, sorry. Okay. That was the reason we removed this feature from Firefox OS and from the Gecko engine. It was because it was insecure. What happened if I fish in a bank with a texture or something like that, and what if I use my application to capture the passwords or okay. There are still security considerations, but as far as I know from the specification, if you do cross-domain, then the texture is read only, okay? And the input and the positioning of mouse or whatever is covered, so you don't get access to those elements, to those actions, okay? But of course, we are still discussing how to enable common paths of interaction. Another feature is that only when you do same origin iframing, then you can access the events happening on the iframe. But the specification is there. I can show you after, and we can see more details in the specification. Okay.
And Danny, you introduce yourself and tell us what you do. The idea is, if we ask a question, let's all introduce ourselves so we can get to know each other.
And of course, I'm not the authority here, okay? And nor any of the. So, if someone else know about this specification, this dumb to tester specification, and want to jump into the conversation, please do it, okay? So perhaps you have the correct answer. Perhaps I'm totally wrong.
Yeah, thank you. I don't have the correct answer, but we have been thinking about how to do things like the Oculus Dash, which forces things to be in the foreground. So that's a great solution for at least getting some people on board. I'd love to talk about that. And as Diego said, I should introduce myself. I'm the founder of LearnBright, which is a WebVR platform for commercial use. Uses WebRTC, works across all devices. Is probably one of the most mature social VR platforms, but hidden behind corporate firewalls. But I'd love to show you guys on Slack. There's a link to this conference being streamed in a 3D environment. Everyone has an avatar. You just have to get an invite with an email address. But that's all running. I'd love to do a talk later on if anyone wants to see what we're doing. But yeah, you're all invited. Yeah, I sent some of the people who I had connections with on LinkedIn, I sent emails to. But those that I don't, just DM me on Slack. Thanks. Oh, I have probably a question for Rick regarding WebRTC. It's fantastic on high-level hardware. We've run a few tests with streaming into Oculus, Gear VR, and these sorts of things. How have you found performance of WebRTC in mobile?
Yeah, thank you. My name is Rick. I work for Tino. I gave the presentation a few minutes ago. We've been doing some testing with different sound sources, and there we notice a very big difference in quality between the devices. So, for instance, the Oculus Rift microphone has lots of crosstalk with an environment. Maybe I think you were referring to the network qualities of the audio. I haven't run that many experiments on mobile yet, so I can't really go into detail there. Yeah.
Quick note, so I'm Fabian, I do WebVR development, and I'm with Lucid Web. Yeah, for the first remark on the iframe and the dump to texture, so it was by Brandon Jones at Chrome during SciGraph. And the same argument was for link traversal last year. It's since you control composition, then if, for example, the decision is it has to be same domain or something like this, then you say, oh, you put, for example, a 360 a circle around to say, hey, that's a non-secure domain, or hey, that's a different domain. So because the browser controls the composition, then if the rule is, yeah, that's not something that we consider safe, we display something that cannot be overwritten. That was his suggestion then.
Yeah, I've come up with a remark on your question. Yeah, but one thing we noted when doing our experiments is that stereo audio and 3D positional spatial audio is very important. And I think for a mobile phone, you would need some kind of headphones or earphones to, well, greatly improve the experience. So that's at least something which you need to take into account when developing for mobile.
All right, so yeah, I'm Ada from Samsung. This is a question for the browser vendors. For the other browser vendors. So Samsung Internet has a couple of non-WebVR APIs for dealing with immersive content. The ones I'm specifically thinking of are the Change Sky API and the HTML attribute type is 360 on video and image elements, which is a HTML API. Do any of the other browser vendors have thoughts on those APIs or want to implement them themselves? Because it'd be cool to get them standardized.
I can't comment specifically for Google Chrome, but I know that we're very interested in solving the problem. Sorry, Brennan, can you wait for the microphone? Yeah, sorry. I was saying I can't comment specifically for Google or Chrome, but I know we're very interested in solving the 360 video problem. One question I was curious about when I saw the extension for Sky modification is how you're planning on carrying that forward to 6-DOF systems in the future. Because the Skybox is usually most effective with a 3-DOF system.
As far as I'm aware, we haven't done any tests with Samsung Internet in a 6-DOF system yet, because currently we're only for Gear VR. But as more headsets come out, if there is a 6-DOF one that runs Android, which I think there might be, I think the Samsung Go maybe. I don't know. I'm not sure. Is that 3-DOF as well? Okay, so it's not a problem. It's not an issue we've encountered quite yet. Yeah. But because skyboxes tend to be at infinite distance, I can't see it being like a massive issue. It'll just be like it's the sky. Yeah.
So hi, I'm Thomas from Virtulip, doing, stand up. Okay, sorry. So yeah, I'm Thomas from Virtulip. Just to rebound on this, I think the skybox on the Vive at the very, very beginning, before their room now, was like a 360 picture of just like a kind of landscape at the very beginning. Well, I had another question while we're still on browser vendors. There was a question on the WebVR emailing list about improvements of design about insecure domains made by Chrome. We've seen a question made about Mozilla. So I don't know where Sava is now. Yeah. So Mozilla is supposed to be just HTTPS only in the near future, but there's nothing about design saying, okay, you're on an insecure domain, these kind of things. So what about letting the user know where he is, which kind of website he's navigating to, these kind of things across browser? I don't know if I'm being clear. Yes?
Sorry, I was attending about how to solve the
okay.
sound problem, so if you can repeat.
Yeah, so good. So the question is, what will Mozilla do about design, about now when you navigate on a 2D website, you see if you are on an insecure domain name or these kind of things. So what will be done in VR as Google has done so far?
Thank you. Well, all these kind of problems of how to distinguish between the Chromium visuals, because this is part of the mixed content budget. I don't know how to call it. You know, this mark we have when you are in an insecure content, when you are looking at mixed content. So part of it is secure, but part of it is not secure. So all these family of problems, we call it the line of death problems. I don't know if you have heard about it, but the line of death is that part of the browser that you totally know that is part of the browser and not the web content, okay? And we have a lot of problems here, and this is the long way to say that we don't know yet, okay? Sure, we have discussed some ideas around customization. So if you customize your browser space, you will be able to recognize your space from the WebVR space, and then you will be, if we put some elements inside these spaces, then you will recognize that they are coming from the browser and not from the content, but we don't know yet. Okay, but for future purposes, if you want to discuss about it, I think it's called the line of death discussion, you know?
Yeah, sorry. I could talk about this a little bit from the Chrome side. So there's a distinction, actually. You can surf the 2D web in VR, but then once there, you can actually also leap into WebVR experiences. So currently, Chrome doesn't support WebVR experiences that have broken HTTPS certifications. And this is because you don't want to be leaking all of the sensor data that's coming off of the headset to who knows who, you know, some third-party man in the middle. There's a lot more security issues with WebVR than there would be with a typical website, so the security model has to be more robust. There's a similar problem, though, to broken HTTPS certs, where we do have to think about how to display things in VR, in WebVR experiences, which is capture mode, like capture state. So if you're using the microphone, or if you're using the camera or something like that to provide some feature within a WebVR experience, how do we represent that in VR? For Chrome, we're going a similar direction to the way that we inform the user how to back out of the WebVR experience. In general, we try not to touch the experience at all. We try to give the entire space to the content author. but there are a couple times when you need to step in. The way that we're doing that, and this is sort of a user agent thing, is that we're displaying these little ephemeral toasts, and the toasts they use a behavior that we call lazy locking, which means if you look this way, it'll appear here. If you sort of look over, it'll puff back into view so that you can see it, and then after maybe about 5 seconds, it disappears. So we plan to do something similar to that for microphone, camera, capture modes, that kind of thing. So if you request those via an API, the user will still know. They won't drop into an experience and be listened in on by the experience without their knowledge. However, this will sort of dissolve away though after a short amount of time, and the user will just have an what's the word? Basically, it'll be just the user and the content. So
maybe thinking about a way to bring it back at some point. If I'm like, so with link transversal, I can be lost in which websites I'm visiting, and I'm not supposed to see back the 2D interface. So at some point to be able to know where I am and which kind of websites, kind of things. So I don't know if you've thought of that as well.
yeah, this is actually a sticky challenge, and not just because of the user interface problem, but there's actually a lot of security problems as well. So I know maybe Salva can speak to this. Mozilla is taking one approach. So far, Google Chrome, Google hasn't been able to find a way that we feel like there's a secure model that allows you within VR to hop from site to site across domains for this reason, because you might jump to, you know, from good site to bad site and suddenly you're being eavesdropped upon. So I think, you know, if I'm speculating, sort of not as Google, but as like me hand waving, I think that this is a problem that gets solved eventually, but it's a very sticky one because it's entangled within the security model of the web, which is based around same origin.
Dam just reminded me that I need to introduce myself first. So my name is Vladimir Levantovsky. I work for Monotype, which is a company that has a very vested interest in fonts, font technology, and text rendering. And I also happen to be Web Fonts Working Group Chair in W3c. So Salva, question for you specifically regarding one comment that you made in your slides about Pathfinder, I believe. Yep. So, so you mentioned that this is something that will improve text rendering in VR? Yeah. Yes. And so my question in general, again, to you and to every other browser vendor about specifically about displaying text in VR, because believe it or not, text is something that content creators really care about. That's how they communicate, or that's how we all communicate. And VR obviously introduces additional challenges because any perspective transform applied to a text, any well, even if it's in a flat surface in a regular 3D, in virtual reality, where there's additional distortions that introduced to actually make it believable, creates even bigger problem for text legibility. So I'm just wondering, can you describe, because I really don't know, can you describe how text is rendered in WebVR, or in general, at least the path in your Pathfinder?
Actually, I cannot. No, I only know some techniques, but I cannot go deep into a conversation about text. I mentioned because I know there is an ongoing effort to make it clearer, but I'm not the person to answer this question. What I know so far, perfect. We have a volunteer there, and I'm not even commenting what I know. I'm handing over the mic right now.
Okay, thank you. Well, I already told you, but I've been investigating the legibility of text in VR as well, and I think I have noticed is that one of the main problems is also due to the resolution of the display. And text is very far away, and then you only have very few pixels to display text, and that's I think the main reason why it's currently very hard to read, and I'm not sure if there's much you can do about that.
well, the way I see it, so the resolution is obviously one physical limitation, but even if you have, well, even if we just for a second assume that we have infinite resolution, so anything where a perspective transform is applied will cause legibility drops because text has a lot of, very small subtle effects that have to be preserved, and perspective transform is not really conducive to that. But also, again, what I noticed that VR content specifically, in order to be seen as real, as believable for a human, has to be distorted. And actually, that's how it at least appears on screen. It presented in certain distortion, so that when you actually see it, it makes it real. I can hardly imagine that distortion will actually help text legibility. So again, for me, it's an open question. I don't have an answer. I'm just trying to figure out if you guys who have real experiences with that can basically tell me. Thank you.
Yeah, I might be able to give you some directions in there, because there are some research papers on how to improve the general legibility of text due to contrast, that kind of stuff. And that also works for VR.
So I'm looking for problems, because that's the first step to finding a solution.
So a bit on the text. My name is Stoyan. I'm a software architect, and in our company we're doing technology for games, and oh yeah, I have to stand up. So the biggest problem is that usually text was rendered in small bitmaps, which when distorted look awful in VR and in 3D like in games. So what is usually done, what we do in our technology is we use sign distance fields, which significantly improve the quality and the distortion. I know that Pathfinder uses the same basic technique, although they try to do it everything on a GPU. So they try to do it very fast just on the GPU, because usually with distance fields you still rasterize them on the CPU, and then you blow them up or diminish the resolution on the GPU. So the thing is that with distance fields you can have just one glyph in one base resolution, which will work and look good even on different final resolutions, so under a different scaling or distortion. And the problem with that is that, of course, it takes some memory, and Pathfinder is trying to do all that stuff on the GPU. I'm not an expert on that, but I've looked at their implementation. It's quite interesting.
Hello. Yeah, my name is Roland Dubois, and I'm a UX developer and also working on Grabber. My question is to the Google team, because they introduced the distance millimeter as like a defining factor for font sizing in virtual reality. And also a question to Samsung, because they're building interfaces and font sizes, and how do they define the baseline for size, readable size for VR headsets, and in what way can that be manipulated and sized based on the actual screen resolution of the device you're using and the actual comfortable reading size for the person that is reading the text? Because when I did some tests with A-Frame and 20/20 vision charts and stuff, obviously none of that is one-to-one correlated. There's too much distortion. It's depending on the lenses, on the resolution of the device. So how do you guys define what is a readable size, a general size, and how is that being modified and customizable for the person that's actually using the device? So maybe Ada can start, and then we hand to the Google rep.
So unfortunately, I'm pretty sure none of our browser developers, people who actually build the browsers, are here. They're currently all based in Korea and America, and they weren't able to come over. right now, I don't think we actually have any ability to change the default font size in our web browser. So I think the developers probably built it and tested it with users until they found one that worked and kind of went with it. I wish I could give you a more like in-depth answer or actually ask the developer. If you want, I can drop them a message and find out something for you.
Hey, so in Chrome VR in 2D, the virtual screen that gets presented, we present to the content that we have a resolution, I think it's somewhere around 960, but it's basically like a phablet or a small tablet size. And what that ends up doing for us is a lot of the 2D content ends up presenting at a size that is reasonable to work with. So a tricky thing with VR is your cursor pointer. It's very precise, but your hand wobbles. So you get a lot of like jitter, which means you need quite large hit targets. And having that resolution, it does two things. One is that the text appears large enough so the screen door effect doesn't affect the legibility of the text, and the other is that it makes hit targets a bit larger, because content authors have often authored their 2D content responsively so that it'll adapt to those sizes. In VR itself, we use sort of internal guidelines. We use a measurement system that we call DMM, dynamic millimeters. So everything's in millimeters as if it were 1 meter away. And the further something is away, the more it's scaled by the same factor. Excuse me. Anyway, what that does for us is for 2D screens, the hit targets and text size stay the same no matter how far away it is. So for us, the minimum size for buttons is around 64 dynamic millimeters. So that'd be 64 millimeters 1 meter away.
If HTML and CSS was to become adapted for VR, do you think DMM would be like a must-have unit for CSS?
That's an excellent question. I don't know about DMM, but maybe something like it. I think for 2D virtual screens, it's really nice because it allows you to move the screen back in virtual space and all of your hit targets and text sizes stay the same. So that problem, though, you can solve it in a couple different ways. You can also just scale things in the view tree. That's basically what we do is we size everything 1 meter away, and then we just parent it to an object and then scale the object depending on how far it is away. So you can sort of solve it script with script, but maybe something declarative would be interesting.
I'm just here to announce that we're going to break it up here. We're going to go for a coffee break, and we're going to continue at 11:35. I would like to take the opportunity to invite you all to kind of like continue conversations in the coffee break and then do a follow-up sessions. Okay? Thank you.